Okay, in today's lecture, we will discuss the projectile motion. Okay, first we will try to understand the basic concepts of projectile motion, and then we will discuss the all possible cases of the projectile motion along with the numericals. Okay, let's start with the basic of the projectile motion. To understand projectile motion, let us consider a flat surface. We are having a flat surface, and let us consider this is a earth surface. This is a earth surface, and we are having one point A in a flat surface. We are having a one point A, and one person is there standing at a point A. Okay, and that person throws a particle at an angle of theta from the earth. Here at point A, we are having a person, and a person have thrown a particle at an angle of theta from the ground. It is going to follow this path. Now the particle is going to follow the curved path. The particle is going to follow the curved path. Okay, and let us assume the particle thrown at an initial velocity of u. When we have thrown a particle, the initial velocity of the particle is small u. This is the initial velocity of the particle. Okay, this is a curved path. The particle which we have thrown, the particle which we have thrown will be known as projectile. The particle will be known as projectile. And this type of motion is known as projectile motion. This type of motion will be known as projectile motion. The particle which we have thrown at angle of theta from the surface will be known as projectile. The projectile is going to follow the curved path. Okay, and the initial velocity we have assumed we have thrown a particle at an initial velocity of u. This is about the projectile motion. Okay, when we are going to solve the numericals of the projectile motion, or when we are going to derivate the values of different parameters of the projectile motion, to make our calculation easy, we are going to assume few things. To make our calculation easier, I am going to assume three things. Okay, let us see what we are going to assume. The first assumption is that the particle, the projectile you can say, remain close to the earth's surface. We are assuming that our particle or projectile is near the earth's surface. Why? In order to avoid the effect of earth curvature, or in order to avoid the effect of moon's gravity. These things we are going to consider. And the second thing that we are going to consider, the air resistance is negligible. We are not going to consider the effect of air friction or air resistance while solving the numericals of the projectile motion. And the third thing that we have assumed, the acceleration of the particle is then almost constant. We have assumed when we are dealing with the projectile motion, we have assumed the acceleration of the particle is constant. Only one acceleration is there, which is g. G means gravitational acceleration is there. Only gravitational acceleration is there, and we know the gravitational acceleration works downward now. Works downward. This is our assumption that the acceleration of the particles is almost constant. Okay, we need to consider these 3 points while solving the numerical of the projectile motion. Okay, now we will discuss the different parameters of the projectile motion. We will try to understand the different parameters of the projectile motion. For that, let us consider a flat surface. This is a flat surface, and here we are having a point A. From point A, I have thrown a projectile which follows the curved path like this. I have thrown a projectile at angle of theta from the horizontal axis. I am naming this as a x-axis. This is my x-axis. I have thrown a particle from point A at angle of theta from the ground. When I have thrown a particle, the initial velocity of particle was u. What is the u over here? U is the initial velocity of the particle. Initial velocity of the particle. Okay. Similarly, consider a y-axis. This is my y-axis. Okay. This is y-axis of the projectile motion. This is just simple diagram. I have considered a horizontal plane as a x-axis. I have drawn a y-axis. Okay. The displacement of a particle in the x-axis. The displacement of the particle in x-axis will be known as the range of the projectile. This is a range of the projectile. How far you have thrown the projectile in the x-axis will be known as range of the projectile. The displacement in a x-axis will be known as a range of the projectile. Similarly, this will be known as height of the projectile. How far the projectile have moved in a y-axis. This is known as height of the projectile. Or you can say this is the maximum height of the projectile. Okay. Now, as we know, the velocity is a vector quantity. Now, we know velocity is a vector quantity. Velocity is a vector quantity, vector. So, the velocity vector u, for the velocity vector u, I am going to find its component. Here, it will have a x-axis component like this. And it will also have a y-axis component like this. It will have y component like this. Okay. As we know, suppose we are having one vector, it will have an x-axis component, it will have a y-axis component. If this is x-axis and this is y-axis, this is suppose vector A. How to find the x-axis component, which is making angle theta from the x-axis? It will be A cos theta, and this is going to be A sin theta. Similarly, I am going to find the x-axis component of the initial velocity vector u, and I am going to find the y-axis component of the initial velocity vector u. This is going to be how much? This is going to be u of cos theta, and this is going to be u sin theta. Is it okay? Okay. The x-axis component of the velocity is going to be u cos theta, and the y-axis component of the velocity is going to be u sin theta. U sin theta and u cos theta. If u is the initial velocity of the particle, can I say u cos theta is the initial velocity of the particle along the x-axis? Similarly, u sin theta is the initial velocity of the particle in the y-axis, in the vertical motion. Okay, now if you notice one thing in the projectile motion, that when the projectile is traveling from position A to position B, this is a position B, the end point. Okay, when the projectile is traveling from position A to B like this, suppose at this point the velocity is like this. When the projectile is traveling from A to B, it is moving in x-axis and it is also moving in y-axis. It is also moving in y-axis. Suppose when the projectile is at this point, it is moving in y-axis and it is moving in x-axis. For every point in a projectile motion, the projectile is moving in two directions, x-axis and y-axis. Or we can say it has a two components, x-axis component and y-axis component. So, can I say in a projectile motion, there are two motions. There are two motions. x-axis motion and y-axis motion. X-axis motion and y-axis motion. And these two are independent of each other. These two are independent of each other. Always remember, for a projectile motion, the x-axis motion and the y-axis motion is independent of each other. You need to just remember this. We are going to use this when solving the numerical. Okay. Now, we have discussed when the projectile is moving, it is having an x-axis motion and it is having a y-axis motion. It is moving in x-axis also, it is moving in y-axis also. Suppose the projectile have covered a distance from point A to this. It means it have covered some distance in x-axis also and it have covered some distance in y-axis also. That's why I am saying it is moving in x-axis also and it is moving in y-axis also. Okay. As we know, the x-axis and y-axis, there are two types of motions in a projectile motion, and these motions are independent of each other. Independent of each other means they are the independent motion. And if you will look in a previous topic, I have discussed there is only one acceleration in the projectile motion, which is gravity, which is acceleration due to gravity. And we know the acceleration due to gravity works downward, which is working in y-axis, It means when the projectile is moving, the acceleration is in y, and which is g, gravity, which is due to gravity. Gravitational acceleration, and there is no acceleration present in x-axis. Remember this point. We are having only one acceleration in a projectile motion, which is a of y. It means we are having acceleration only in y-axis, which is because of gravitational acceleration, and we are not having any acceleration along the x-axis. Okay. Now see how to write the equation, how to use these properties, how to use this concept while solving the numerical. We will see. Okay. What are the three equations of the straight line motion? We know now. The first one is V is going to be U plus AT. The second is what? S is going to be UT plus half of AT square. And the third one is V square is equal to U square plus 2AS. Okay. These are three equations that we are going to use for the projectile motion. Okay. What is a V over here? V is a final velocity. V is a final velocity. Okay. What is a U represents here? U represents the initial velocity. Initial velocity. What is the S? We know for the straight line motion, we are considering S as a displacement. Displacement. What is the A? A is the acceleration. And what is T? T is a time. T is a time. These three equations we are going to use in a projectile motion. Here we can see there are two motions in a projectile motion, x-axis motion and y-axis motion. And they are independent of each other. When we are going to solve the numerical, at a time we will use one axis. Either we will use x-axis or y-axis. While solving the numerical, you will see, or when we are going to find the parameters values, we will use one axis. Either we will use x-axis motion or we will use y-axis motion. Okay. Now I am going to write equations. I am going to modify these equations for the x-axis and for the y-axis. Now we will see how to write an equation for the x-axis and y-axis. I am going to modify this. I am going to modify this equation for x-axis and y-axis, I will use these equations. The equation that we are going to get after modification, we will use those equations for the x-axis and y-axis. Okay, let's see how to modify these equations for the x-axis. X-axis. We know the x-axis is a horizontal motion, now. Horizontal motion. Now let's see how to write these equations for the horizontal motion. Okay. Now look at this diagram. Now look at this diagram. When we are using the horizontal motion, when we are discussing about the horizontal motion, what is the initial velocity? When we are discussing about the horizontal motion, what is the initial velocity? You will see this is the initial velocity for the horizontal motion. It means I will write initial velocity of x-axis is u cos theta. Okay, and we know acceleration in the horizontal is 0. I'm going to use these two things to find the equation of the horizontal motion. Okay, the first equation is v is equal to u plus at. How to write? Write x and the base to represent the x-axis. I have marked as to show that this is a x-axis or horizontal motion equation. Okay, what is the final velocity of, what is the vx? V is the final velocity along x-axis. What is the u of x? U of x represent initial velocity along x-axis. Or you can say, instead of x-axis, it's better to say horizontal motion. Okay, what is the a of x? A is the acceleration along x-axis. Horizontal motion. This is a horizontal motion. Oh, now I'm going to modify this equation. V of x is equal to u of x, and we know a of x is 0 now, because acceleration in the horizontal is 0. It means this is going to be my first equation. This is going to be my first equation. Ux is going to be Vx. It means for every point in a horizontal motion, initial velocity and final velocity is going to be same. This is the first equation I'm going to use for the horizontal axis. Now, how to modify the second equation? We know now the second equation is s of x. First write the equation as it is, s u t plus half of a t square. Write this x now because it represents the x-axis motion or horizontal motion. Okay, now I'm going to calculate the s of x, which will be equal to u of x multiplied by time. As a of x is 0, it means this term is going to be 0 now. So I will write s of x is equal to u of x t. This is a second equation for the horizontal motion. And just I am modifying this equation. I am modifying these equations using these properties. Okay, how to write a third equation of a horizontal motion in a projectile motion? Okay, what is the third equation? V square is equal to u square plus 2as. Write x over here, x over here, x over here, x over here. As we know, this term is going to be 0 now. Why? Because a of x is 0. So can I write like this? V square and u square, x is going to be same between v of x is going to be u of x. Same as the first equation. No? Equation number 3 you can say. Similar to the equation number 1. These are the equations that I am going to use while solving the numerical or while finding the values of the parameter while using the horizontal motion of the projectile motion. As I told, x-axis motion, that is horizontal motion, is independent of y-axis motion. We will see. Okay. Now, I am going to modify the straight line equation for the y-axis motion. Write down y-axis motion. This is the x-axis motion. These are the three equations that we are going to use for the x-axis motion and y-axis motion. I'm going to write for the y-axis motion. Okay, I'm going to write the equation first here. In order we will get a same equation on the same page, it will be easy for us to understand. V is going to be u plus at is the first equation, and we know s is going to be ut plus half a t square is the second equation, and v square is going to be the u square plus 2as is a third equation. This is equation number 1, this is equation number 2, and this is equation number 3. And as I told, in a y-axis, there is an acceleration. Now, there is an acceleration a of phi, and which is because of gravity. Now, gravity g. Okay. While solving the numericals in the gravity, free falling object under the gravity, we have taken this as a positive direction and this as a downward direction. This is a upward, which is a positive, and this is a downward, which is negative. The same convention I am going to use. This is a sign convention that I am using. This is a sign convention that I am using. Okay. Ay, na, gravity works downward, that I will use sign minus. Okay. Now if you look at the initial velocity in the y direction in the above diagram, what is the initial velocity for the y-axis in this diagram? This is the initial velocity of the given projectile in the y direction. This is the initial velocity in the y direction. This is the initial velocity. This is the initial velocity in the y-axis. Okay, now we are going to modify the equation. The first equation is what? This one I'm going to modify. V is equal to u plus at is the original equation. I'm going to write y, y, y. Okay. V of y same. U of y, I'm writing u of y because we know u of y is this much, no? Okay. What is the a of y? What is the acceleration in y? This is minus of g, and this is t. This is my first equation of the y-axis. This is the first equation for the y-axis. I'm using this thing, huh? I'm not writing in this equation, instead of u of y, you can write u sin theta. Instead of u of y, you can write u sin theta. Okay, now I'm going to modify the second equation. The second equation is like s is going to be u of t, ut. Okay, now I'm going to modify the second equation. Second equation is equal to s ut plus half of a t square. I will use y in order to represent that I am discussing with the y-axis. Okay. S of y is a displacement in y-axis. What is the u of y? U of y is a u sin theta. I am just writing u of y, huh? T. What is the a of y? A of y is a minus g. It means acceleration in y-axis is minus g, na? That's why I am using a minus g. T square. This is my second equation while solving the motion along the y-axis in a projectile motion. Now look how to modify the third equation. The third equation is v square is equal to u square plus 2as. Okay, use y in the base to represent it is the y-axis. Okay. Vy square is going to be u of y square. U of y is u sin theta. Instead of a by, I will use minus of g, na? Minus of g. S of y. This is my third equation. This is my third equation for the y-axis motion. Okay. These are the equation for the x-axis, and these are the equation for the y-axis. Just I have modified. I have put out the value. Okay. Write down here. What do you mean by v of y? V of y is a final velocity. Final velocity in y-axis, or you can say vertical motion. Again, what is the u of y represent? U of y represent Okay, u of y, what it represents? U of y, it represents the initial velocity of y-axis. Okay, now what is the meaning of s of y? Displacement in y-axis. I'm not writing about displacement in y-axis. And t is a time. T is a time. Time is going to be same for the x and y. Time we are going to take same. Just remember these things. Now you used to remember these three equations of x-axis or motion. You can say horizontal motion, and y-axis motion, or you can say the y-axis motion is also a vertical motion. This is a vertical motion. Okay, when I'm going to solve the numericals or find the values of parameters, either I'm going to use these three or I will use these three at a time. Okay, in the same numerical, if suppose it is required, we will use a y-axis motion also and x-axis motion also. But when we are discussing about the y-axis motion, we will use these three equations. And when we are going to discussing the x-axis motion, we will discuss these three equations. Okay, now let's see the different cases of the projectile motion. Actually, no need to write this in a note. When we are going to discuss the projectile motion, the three types of cases we are going to discuss. First, this one. The second is like throwing a projectile from the tower. Here we will have a two case when it is thrown like this, and another when it is thrown like this. This is a tower. Don't worry, I'm going to write these things. This is the case number 1, simple projectile motion. Sorry. And the second case, we are going to throw a projectile from the tower. And the third case, we are going to discuss the projectile in an inclined plane. This is the third case that we are going to discuss. In inclined plane, we will discuss the two cases. In one case, we are going to throw a projectile from the base like this. And in one case, we are going to throw a projectile like this. We will see these three cases in a projectile motion. We are going to solve the values for these three type of cases. Okay, let's start with the case number 1, the simple projectile motion. Now, most of the cases in exam, you will find the numerical form, this case. Okay, write down projectile motion, case number 1. Case number 1. For that, let us consider let a particle is projected with initial speed of v, with a speed of u, initial velocity u, at an angle theta from the x-axis, at an angle theta from x-axis. Okay, let us see how to draw a diagram. What we have done here, we are having a flat surface and from this point you can say point O, we have thrown a projectile like this. This is point O. Okay, and this is the point A I am considering. This is the point A where the ball have reached finally. Okay, now draw the y-axis. In every case, we're going to do the same thing. Draw the x-axis and y-axis. This is x-axis and this is y-axis. I'm going to use x-axis as a horizontal motion for the horizontal motion and y-axis for the vertical motion. Now draw the u, the initial velocity. And we have thrown a projectile at angle of theta now. Okay, if this angle is theta, what is going to be the velocity vector? Initial velocity vector in x-axis, it's going to be u cos theta. And this is going to be the u sin theta. U cos theta and u sin theta. These are the basic things in a case number 1. And now we are going to find the different parameters. Okay, write down the first parameter that we are going to find, time of flight. Time of flight. Time of flight means for how much time the ball was in air. For how much time the ball was in air. it represents for how much time, you can say projectile, a particle or ball was in air. Whatever you are considering was in air. Or you can say it is equal to the, it is same as time taken by projectile to reach point A from point O. This is same now. Time taken by projectile to reach from point O to A. Or you can say for how much time the projectile was in air. Now let's see how to consider, how to find the value. Okay, for the calculation of the time, always remember, for calculation of the time, I'm going to use the y-axis. I'm going to use a vertical motion. And as I told, both are independent of each other, no? Vertical motion and horizontal motion. I'm going to use a vertical motion. The second equation of the vertical motion, you can say s of y is equal to u of y t minus half g of t square. This is the second equation of the vertical motion in a projectile. Okay, now what we are calculating? We are calculating a time of flight. Means when the particle have traveled, let us consider you can say particle, projectile or ball, whichever you are using. Consider projectile has taken t time to reach point A. It has taken t time to reach a point. It means our time is t. Okay, the time is t. Can you say what is the value of s of y? When the particle have moved from this to this, what changes? What is the displacement in y-axis? The particle started from point O and it have reached the point A. What is the displacement in y-axis? 0, na? S of y is 0. It have moved in x-axis. It have covered some distance in x-axis, but it started from here. Distance is like this. But here, when we have reached the point O, you will say displacement is 0, na? S of y is a displacement, na? The initial and final point is 0 as per the y-axis. In the x-axis, it have made some displacement, but in y-axis, it is 0, na? It means the y-axis, this S of y is going to be 0. Okay, let us see again what I am saying. When you have thrown a projectile like this, suppose this point we are having a coordinate 0, 0 origin, and here what coordinate we will have? Suppose it have traveled x distance in x-axis, x comma 0. Now because y coordinate is also 0 at this point, because it is the x-axis, it means how much distance it have traveled in y-axis? 0, na? Initially 0, finally 0. Even total displacement in a y-axis is 0. Total displacement in y-axis is 0. Okay, so I will write S of y is 0. And the time taken by the ball to complete the journey, for the time it was in air, I will say t is going to be capital T. Now put these values. Okay, S of y is equal to, I will directly put the value 0. Okay, and we know what is the u of y. We know u sine theta. Now initial velocity along the y-axis, this. Okay, capital T minus half of g t square means capital T square. Now solve it. Half g capital T square is equal to u sine theta capital T. T and T square got cancelled. From here you will get the formula like T is going to be U sine theta multiplied by 2 now. I'm taking these 2 on this side and this is going to be T. Okay, this is a formula to calculate at flight time or time of flight for the projectile motion. For this much time the ball was in air. For this much time the ball was in air. You can write for T time projectile or ball or particle projectile was in air. Was in air. Okay. The only thing while solving the value of this parameter S of y is 0. Why? Because we know the ball have moved 0 displacement. Ball have moved 0 in a y-axis. How much it have moved? 0 and 0. Even total displacement in y-axis is 0. That's why we have taken S of y. Displacement in y-axis is 0. If it was asked, if we are using the S of x is x. Here the ball have moved x in a x-axis. Okay, now let's see the second parameter. The second parameter. First we have calculated a time of flight. Now we will calculate the range. Case number B. Time of flight. Now we are going to calculate the range of the projectile. Range means, as I already told while discussing the first topic, range is a distance traveled by the projectile in a x-axis. So we will use which type of motion? We will use the horizontal motion. We will use horizontal motion. Remember, to calculate a range in any case we are going to use a horizontal motion. Okay, as we just I'm drawing a rough diagram here. This is x-axis, this is y-axis, this is my projectile. This is initial velocity, this is velocity along the x-axis, this is the initial velocity along the y-axis. Or what is u of x? U of x is equal to u cos theta. Okay, and this is my x-axis, this is my y-axis. In this diagram, what do you mean by the range? This is a range. This is a range. Okay, to calculate the range, I'm going to use the second equation of the horizontal motion in projectile. Okay, what is the second equation? S of x is equal to how much? U of x t. Now we know because a of x is 0, the term half at square, when we are going to put the ax is going to be 0, we got the 0. Now that's why I'm going to use a second equation. This much. Okay. S of x I am calculating now. S of x, displacement in x-axis. S of x is displacement in x-axis. What is displacement in x-axis? This is r na. What is the u of x? Initial velocity in x-axis, u cos theta. And what is the t over here? It is a time. It is a time to reach ball from here to here. Na? If you will see, to reach a ball from here to here, from point O to point A. Is it same as a flight time? Yeah, because we have written over here how much time the projectile was in air. For how much time the projectile was in air is same as time taken by the projectile to reach from point O to point A. It means this time. In order to calculate a time, we are going to put a value of t as the time taken by the projectile to cover a distance of r. The time taken by the projectile to cover a distance of r is 2u sine theta upon g. Now, the same value of t I am going to put in this formula. T. It means the range will be equal to u cos theta multiplied by 2u sine theta divided by g. Now solve it. R is going to be u. Here we are getting a u square na. 2 cos theta multiplied by sine theta divided by g. We know the identity 2 cos theta into sine theta is equal to sine of 2 theta. I'm going to write this. R is going to be u square sine of 2 theta divided by g. This is my formula to find the range of the any projectile which is thrown at angle of theta. This is the range of the projectile. Remember this, when we are calculating a range, we have discussed the horizontal motion and we have taken time this now. Why? Because this is a time for which ball was in air. This is a time for which the ball have covered a distance from O to A. This is a time taken by the projectile to reach from point O to A. Time taken by the projectile to reach from point O to A. This much distance ball have covered or projectile have covered. Now we will calculate the maximum height reached by the projectile. Maximum height reached by the projectile. Let's see how to calculate. The third parameter is a maximum height reached by the projectile. Maximum height reached by the projectile. For that, every time just draw the rough diagram of the projectile like this. Here we are having a flat surface. This is my projectile. This is the x-axis. And always draw the y-axis like this. This is y-axis. Initial velocity is u. And this angle is theta. And the x-axis initial velocity is u of x, which will be equal to how much? U cos theta. And y-axis initial velocity is u of y, which is equal to u sin theta. Okay. Suppose this is a maximum height. This is a maximum height the ball have reached or the projectile have reached. Okay. If you will see, when the projectile will be at the highest point, when the ball will be at or projectile will be at the highest point, it will start falling. After that, the ball will start falling. If this is a first phase that it have covered, then after this, the projectile is going to be moved downward. Okay, let's see. For what is the total time for which the ball was in air? It is a 2u sin theta divided by g. We have calculated in the first equation. Okay. This is the time for which the ball was in air. This is the time for which the projectile was in air. It means the t. What is the time to cover the half of the journey? What is the time to cover the half of the journey? Or you can say, suppose this is the point B. What is the time at which the ball was ball or projectile was at point B? It is the u sin theta divided by 2, half of this time. Half of this time. This is equal to half of this time. It means if the projectile was in air for that much time, at t is equal, at small t is equal to capital T by 2, it means the half of the flight time it have taken to cover this red color shown line to reach the highest point. It is a time to reach the highest point. Time to reach highest point. Time to reach the highest point. Okay. Now we are going to use a second equation of the vertical motion. Second equation. Okay. If you are not able to remember the equation every time, no need to worry. Just write the straight line motion equation. S is going to be u of t plus half of a t square. Now put base as a y now in order to represent the y-axis or vertical motion. Now what we will do? We will replace the value. S of y is going to be u of y. T, ay is minus of g now in a vertical motion. G, t square. This is the second equation of the vertical motion. Okay, now see, what is the S of y? When we are calculating a maximum height, what is the displacement in y-axis? The displacement in y-axis is same as h na, maximum height. Displacement in y-axis is h. Okay, what is the u of y? Initial velocity. Initial velocity is u sin theta. What is the t? Time taken by the projectile to reach the maximum height is u sin theta upon g. This value. T. Okay. Minus half of g and t square. T is a time na, u sin theta divided by g square. Now solve this and you will get the formula for the maximum height of the projectile. H is going to be how much? U square sin square theta divided by g minus half G U square sin square theta upon G square. G and G square got cancelled. You will get H is equal to U square sin square theta upon G minus half of U square sin square theta divided by G, which will be equal to how much? U square sin square theta divided by 2G. This is the formula for the maximum height of the projectile in this case. In a simple projectile motion, this is the maximum height the projectile have reached. And this is the time taken by the projectile to reach the maximum height, half of the flight time, Okay, now we will see the maximum value of range. And for what condition we are going to get a maximum range. So put a next heading G, maximum range. Maximum range of the projectile. Okay, previously we have calculated the formula for the range as U square sine of 2 theta divided by G. This is the formula for the range that we have calculated. Okay, for what value of this term? For what value of this term we will have a maximum range? If this value is going to be maximum, if this value is maximum, it means we will get the maximum range. If this value we will have a maximum value, the range is going to be maximum. Okay, we know for the sine theta, the maximum range is 1, because the value of sine theta lies between -1 and +1. It means the maximum value we can take for the sine 2 theta is 1. So can I write the R max will be equal to U square divided by G, because we have taken sine 2 theta as 1. This is the maximum value of range that we can get. If we are throwing a projectile for this much speed with this much of initial velocity, the maximum range we can get is this much. Okay, at what condition we got this formula? We got this formula when we have taken sine 2 theta is going to be 1. It means 2 theta is going to be sine inverse 1, which is equal to 90 degree. It means theta is going to be 45 degree. If we are throwing our projectile at angle of 45 with initial velocity of u, you will get this much range. Maximally you can get this much range. This is a formula for the maximum range, and this is a condition for the maximum. This is a condition for maximum range. Condition for max range. That's why if you will see any javelin thrower, any player in a javelin throw game, they used to throw a javelin at angle of 45 degree. They throw a javelin at an angle of 45 degree. So it will cover the maximum range. In order to throw it a maximum range, they used to throw a javelin at angle of 45 degree. Okay, this is all about the basic projectile motion. Okay, now before moving to the numerical of this case number 1, we will see one more topic. We are going to discuss the trajectory equation of the projectile motion. We are going to discuss the trajectory equation of this case number 1. Okay, you can say the point E, trajectory equation. This is very important, and we are going to use this for the other cases. Trajectory equation. How the point x, you can say how the coordinate x and coordinate y of the projectile motion are related to each other at any point of the trajectory. I'm going to draw a diagram, and here I am having a projectile motion like this. This is point O, this is point A, and always draw the y-axis like this. As I told, draw the y-axis. This is my y-axis. This is my x-axis. I have thrown a ball or projectile at a velocity u. This is going to be how much? This is going to be u cos theta if this angle is theta. and this is going to be u of y, which is u sine theta. Okay, this is the basic diagram for the projectile motion. What do you understand by the trajectory equation? Okay, let us consider for after traveling a time t, the projectile is at this point B. It is at point B at this, and it is having a velocity of v of 1. Okay, to reach a point B, or when we can say when the projectile have reached the point B, how much distance it have traveled in y-axis and x-axis is like this. For x-axis it have traveled this much distance, and for y-axis it have traveled this much distance, y, and this is x. Okay, suppose the projectile is at this point, then when the projectile is at point C, what is the value of x-axis displacement? This is the x-axis displacement, and this is my y-axis. Change the color. This is my y-axis displacement. This is my y-axis displacement. This is s of y for point C, and this is s of x for point C. We can say, what is the relation between s of x and s of y? What is the relation between the coordinate of any point? How to write? The trajectory equation will be given like y is equal to x tan theta 1 minus x upon. This is a trajectory equation of the projectile motion. The derivation is very easy, but I am not going to derivate now. That's not very important for us. Only the trajectory equation is important for us. That's why I have written like this. Suppose when the projectory, just try to understand, when the projectile is at point C and the coordinate of point is x comma y. I'm just writing a diagram like this. Wait. Suppose the trajectory is at point C and the coordinate of this point is x comma y. Then how the x and y are related to each other? You will use this equation. This is known as a trajectory equation of the projectile motion. What is the r over here? R is a range. You will need to put the formula of range. What is the theta? Theta is the angle of the projectile from the x-axis. Now you can say initial angle from the x-axis. Angle from x-axis. Okay. For any point, suppose this is a point D. If you want to calculate a relation between the x-axis coordinate and y-axis coordinate, you will use this point, this equation, trajectory equation. This is a trajectory equation of the projectile. You need to remember this. It's very easy to derivate. If you want, you can check the books, but it not require. Okay. Now we will see the numerical for this topic. Now let us see a question number 1. Question number 1. What it states? A football is kicked with a velocity of 20 meters per second at an angle of 45 degrees with a horizontal. Okay. Now draw the diagram first. It is given from here, that is, this is the point O. From here, a football is kicked at what angle? At angle of 45 degree. And the initial velocity is 20 meters per second. Initial velocity is 20 meters per second. And in a course it is given, we need to use G as 10 meters per second square. We know the actual value of G is how much? 9.8, no? But default we are going to use 10 per second square. Okay. This much is given in the question. Let's see what it is asking. Before that, always draw the y-axis. This is my x-axis. This is my y-axis. Okay. The first part, it is asking time taken by the ball to strike the ground. It means we have kicked a ball at point O. Suppose this is point A. It have reached the point A. It is again hitting the ground at point A now. What is the time taken by the ball to reach from O to A? It is same as flight time, or it is a time which ball have taken to reach from point O to A. What is the formula for that? We know now. The time will be equal to how much? What is the formula? 2u sine theta divided by g. This is the time taken by the ball to reach the point A. Point A is the point where again it is going to hit the ground. Okay, the time t will be equal to 2. What is the initial velocity? It is given as 20. What is the sine theta? Theta is a 45 degree, sine of 45, and we know the g is given as 10. Okay, 10, this is going to be 0, this is going to be 4. What is the value of sine 45? 1 upon root 2. 1 upon root 2. So I'm going to write 2 multiplied by 2 divided by root 2, which will be equal to 2 root. This is my final answer. This is the time taken by the ball to reach the point A. Or you can say it is a time taken by the ball to hit the ground again. This is the answer for the first option. Okay. Now look at the second option. What it is asking? Find the maximum height it reaches. Okay. Now it is asking what is the maximum height the ball have reached. This is the maximum height the ball have traveled. Okay. What is the formula for the h? H we know is equal to the u square sine square theta divided by 2g. This is the formula for the maximum height that we have calculated. What is the u square? This is going to be 20 multiplied by 20. What is sine theta? Sine of 45 degree square divided by 2 multiplied by g is 10. Okay. This 10 and this 2 got cancelled. This 2 and this 2 got. If we are getting 20 multiplied by sine of 45 square means sine of root 2 square, which will be equal to 20 multiplied by 1 upon 2. It means we will get h is equal to 10 meters. The maximum height the ball reaches is 10. Is it okay? Okay. Now look the third question what it is asking. Part C. How far away from the kick does it hit the ground? It means it is asking this distance. It is a range for us. No? It is a range for us. It is asking how far the ball has hit the ground. It is asking for the range. Okay. What is the formula for the range? What is the formula for the range? We know now. Range is given by u square sine 2 theta divided by g. Now put the value. U square means 20 multiplied by 20 sine of 2 theta. Theta is 45. 2 theta is going to be 90 now. Divided by g, which will be equal to 20 multiplied by 20. What is sine 90? Sine 90 is 1. G is 10. This is going to be 2 times. It's going to be 40. What is the range? Range we have got in this case 40. And it is, just notice what is the theta. Theta is 45 degree. No? It means this is also maximum range. We can say this is a maximum range. With this much velocity the ball can travel. This is the R max because theta is 45 degree. Okay. Now look at the fourth part. What it is asking in a question. If angle is changed to 60 degree, then how far or less the ball will hit the ground? Okay. It is given now theta is 60 degree. We know now the maximum range is at angle of 45 degree. Maximum range is at 45 degree. Any angle other than the theta will have a less range. It means this range is for the 45 degree. It means for theta is equal to 60 degree, we are going to range less than 40. Na? For this value of theta, range is always going to be less than 40. Why? Because this is a range for 45 degree and we know the range is maximum for the 45 degree. Now calculate. Go calculate. For the angle theta is equal to 60. What is the formula for range? Range is the u square sine of 2 theta divided by g. Okay. Now put the values. Okay. It will be equal to u square 20 multiplied by 20 multiplied by sine of 2 theta. Theta is 60 in this case. It means it's going to be 120 divided by 10. Now put the values and solve it. Okay. What you will get? This is going to be 2. Then you will get 40 multiplied by sine 120. Now solve it. It's going to be 40 multiplied by sine 120 root 3 divided by 2, which will equal to 20 multiplied by root 3. It means the range for the angle 60 degree is 20 multiplied by root 3. Now put the value of root 3. Let's check what is the exact value. 20 multiplied by 1.732. It's going to approx 34.64, which is less than 40 now. It means whenever we are increasing or decreasing the angle, when the angle is other than 45 degree, the range is going to decrease. Okay, this is a range for the angle of 60 degree. Okay, now look at another question, question number 2. Question number 2. Let's read what it is asking. This is question number 2. What will be the speed of the stone when it is flying at any general angle? At any general angle, say phi with the horizontal, when it was initially thrown at angle of theta. Okay, it's very easy now. Let's see. Here we are having a plane surface and we have thrown a projectile. We have thrown a stone like this. Okay. This angle is theta, as question says, when it was initially thrown at angle of theta. Okay. Now, first what we need to draw? We need to draw a y-axis. We are drawing the y-axis. And draw the x-axis. This is my x-axis. Okay. Suppose this is any general point B. This is point O, this is point A, and this is point B. And at point B, the velocity of the ball is V. Stone is here. The velocity of this is V1. Let us consider V1. And this point is making angle phi from the horizontal. This angle is making phi from the horizontal. It's making phi from the horizontal. Okay. Let us consider the initial velocity as u. Initial velocity of the given as u. Okay. Now it is asking what will be the speed of the stone what is flying at general angle, say phi. Okay. Now let us calculate the horizontal and vertical velocity. Suppose this is u, then what will be the value of this? This is going to be u of x, which will be equal to u cos theta. And what will be the uy? Y-axis initial velocity, it is going to be u sin theta. Okay. Now consider the point B and let us calculate the horizontal and vertical velocity for the point B. This is going to be how much? This is going to be v cos of phi, and the vertical is going to be v sin of phi. Is it okay? V1, no? V1. V1 cos phi, V1 sin phi. Okay. Now see, as we know, the acceleration in the horizontal axis is 0, no? U of x is always equal to V of x. We know this thing. For the horizontal axis, initial and final velocity is always going to be same. What is the initial velocity for the point O? This is going to be u cos theta in a horizontal axis. And what is the horizontal velocity of point B? The horizontal velocity of point B is V1 cos of phi. Are you getting how I am writing this? Because we know now, for every point on the projectile will have a same velocity in the x-axis. The horizontal component will have a same value because we know the acceleration along the x-axis is 0. Initial velocity will be same as final velocity for any point. So we can write V1, the velocity at point B will be equal to u cos theta divided by cos of phi. It was asking this. What's the velocity of point B? This is very good question. Just remember this, how to solve. We know Ax is 0, acceleration in x-axis, acceleration in horizontal is 0, and we know that the velocity at every point of the projectile in a horizontal means the horizontal component of the velocity at every point in a projectile will have a same value. For any point in projectile motion, or you can say any point in projectile trajectory, we know as ax is 0, horizontal component of velocity will be same. I have used this for solving this numerical. Okay, now we will discuss the case number 2 in the next lecture.